continue with exercise 13. A ball is thrown from the ground with an initial speed v01 equal 25 meters per second. So we have here a ball. It's thrown upward vertically with v01 at instant of time t0. At the same instant, another ball is dropped from a building 15 meters high. So we have here another ball. It's dropped. Dropped means that v02 is equal to 0. So it's dropped from a building of a height of 15 meters. Here h is the height of the second ball at t0. H is equal to 15 meters. Question is, after how long will the balls be at the same height? We are required to find the instant of time t where the ball will have the same height. So here, let's suppose that the ball 1 and ball 2 will have the same height here at this level. This level corresponds to the instant of time t. So let's find the time t. Okay, from the given, we can clearly see that the balls will have the same height if y1 is equal to y2. Then let's find y1 and let's find y2 and make them equal to each other. So we need to find the equation of y1 as a function of time and y2 as a function of time. Before starting, this is an exercise of a free fall object. We can start it like a projectile motion, because here the only forces applied to each of the ball is the weight. So here the acceleration is equal to g. The acceleration is equal to g, and g is vertical downwards. So we can write that ax for v1 for ball 1, a1 is equal to g, and ax is 0, ay is equal to minus g. Why minus? Because g is pointing downwards, and we took the positive direction of y as going upwards. So g has an opposite direction. It's in opposite direction with the positive y. So let's start. For ball 1, we can write a1 is equal to minus g in magnitude. So for the ball 1, we can write that a1x is 0 and a1y is minus g. Okay, this is equal to minus g. This means that a1 is equal to minus g. By integrating, we can find v1 equal minus gt plus v01. Here v01 is given. Then we can find y1. y1 is equal to the integral of v1 dt. We can make the integral and add a constant y01. Here y01 is equal to 0 because we took the origin at the ground. This is the origin O. So y1 is equal to minus half gt squared plus v0t. Similarly, let's find for ball 2 the equation of relating y2 with time t. So we will start with this similarly. a2 is equal to minus g. v2 is equal to minus gt plus v02. Here v02 is equal to 0 because the ball is dropped. The ball 2 is dropped. They said that the ball 2 is dropped from a building is dropped means it's thrown without any speed. And v02 is equal to 0, and we can find y2 equal minus half gt squared plus y02. What is y02? y02 is equal to the height h. Okay, so we have two equations. One is for y1 as a function of t, and the second equation is for y2 as a function of t. Then we can put these two equations equal to each other. y1 is equal to y2, and we can get the value of t. T is found to be equal to h over v01, and this is equal to 0.6 seconds. Exercise 14. A small object is released from rest in a tank of oil. We have a small object which is dropped. It's released from rest and without an initial velocity. v0 is equal to 0 at t equals 0. And we have, so the ball is released from rest in a tank, in a container of oil. The downward acceleration of the object is g minus hv. So this is the expression of the acceleration. They gave us the expression of the acceleration in this exercise, where g is the constant acceleration due to gravity, and h a constant which depends on the viscosity of the oil and shape of the object. So we have many parameters here to find h, but in global, h is a constant related to the viscosity of the oil and to the shape of our object. The question is to derive expressions for the velocity v and vertical drop y as function of the time t after release. So we are asked to find v and y. We have the acceleration. We need to find v and y. How can we pass from a to v and from v to y? Simply by integration. But we need to pay attention to the way we make this integration. We need to separate the variables. Okay, so let's start. We'll start with the definition of A. A is equal to dv over dt, but A is also at the same time equal to g minus hv. This is given. So we make 1 equal 2. So 2 is the definition of A, and 1 is the expression of the acceleration in this exercise. This means that g minus hv is equal to dv over dt. We separate the variables, so dt will come before the equal, and g minus hv will be took to the right hand side. And so dt is separated, time t is separated from v. And then we can make the integral of dt between t initial and t equal to the integral of dv over g minus hv between v initial and v. We know that t initial is 0, and we know that v initial is 0, so we can quickly replace t1 ti with 0 and vi with 0. Now let's make the calculation. So this integral is equal to t minus 0, so it's equal to t, or t minus ti. It's equal to the integral of dv over g minus hv between vi and v. How to find this integral? In fact, we have in the if we let g minus hv equal to a function u, for example, we can clearly see that the du over dv it's equal to minus h. The answer to this integral is ln of something multiplied by something. So here are the details. Let u be g minus hv. Du over dv is equal to minus h. So we can write dv is equal minus du over h. Okay, so this is dv. Let's put this dv here in the numerator. So this integral will become minus 1 over h integral of du, and in the numerator we have the function u يلي هي هون. Okay, and we know that the integral of du over u is equal to ln of u. أكيد يعني بقلب ln should be positive, that's why we added this absolute value. And we can go back to our to this line. So t is equal to the integral of dv over g minus hv between v1 and between vi and v. So this is will be equal to minus 1 over h, as you have seen here, ln of u, and we can replace u with h minus g minus hv, and we shouldn't forget the boundaries v1 and v. Okay, so first we should replace v with v, and then we replace v with v initial, and you can obtain t. In the question, they asked us to find v as a function of t. Okay, so we should adjust the form of this equation such a way to see v equal an expression as a function of time. Okay, so we found equation 4. It's the equation of v as a function of time. Now, from v, how can we find y? By integration. So let's do the same thing. We will write that v equal g over h, 1 minus e minus ht. This is equal to dy over dt. Okay, here the motion is happening along the y-axis, so don't put v equal dx over dt. We should write v equal dy over dt. So let's put equation 4 equal to equation 5. Equation 5 is the definition of v. So we will get this equation. Again, we should separate the variables. dt should go to the other side, and we will deal with this integral form, the integral of 1 minus e minus ht dt. I will remind you the rule of the integral of an exponential. The integral of exponential ax dx is equal to 1 over a e ax. Okay, so simply you have to apply this rule to find the integral of 1 minus e minus ht dt, and you will finally obtain y as a function of time t. Okay, this is an exercise. Here you can find all the details of calculation.